Part A, we can't really do it because I don't have it solved. But do you ever solve on your phone? But I happen to have the model solution here, so I know what they are. Okay, so in a problem like this, first you need to devise a way to solve linear problems, the LP realizations. Normally, you take Mosul and write this in. It takes about 5 minutes when you know what you're doing. So go to the lab a few times and practice before the exam. Okay. The whole code is in the lecture notes in the booklet. I think it's also on Moodle, so if you don't know what you're doing, learn that. Now, when you solve, so then you solve this whole thing without any integer. When you solve this whole thing without any integer, you're supposed to get 0, 7.5, and 0. So I'll start drawing that tree. I'll call this S. Just to be consistent with that. And x1 is 0, x2 is 7.5, and x3 is 0. Suspicious. Oh no, not very suspicious. Yes. Okay. So that's the solution. Apologies. So when if this happens to be all integers, then you're happy and you say, oh, we've won. Solution found. If it's not, then you do what? You introduce new constraints, but in what way? By branching. So you create two subproblems. I'll call them S1. And I'll call this one S2, say. And the constraints you introduce, how do you do that? Yeah, you pick one of the fractional values here. There are several. Well, in this case, it is only one, so that doesn't give us much choice. So one of the sides is less than or equal to 7, and the other side is greater than or equal to 8. So based on 7.5, so 7.5. To the left of it, and then to the 7, and it's at least 8. So which one do you want to solve first? This one? S2? Why? Have you done it? Have you done it already? Okay. So this one is infeasible. That's fine. So this is so next we have to solve S1. What did you get?
X1 is 0.08. With 2 is 7. X2 is 7. And X3 is 0.62.
0.62?
Yeah, and Z is 21.7.
I didn't catch this one. I got something small.
Yeah, 0.077.
So now we have a choice. We need to branch again, but we have a choice. What did you pick? Why?
Because I did it with X1.
You picked X1. And in what sense was it not nice?
Just it.
Is there a rule where you're supposed to pick the highest fraction of pi?
Yes. There is a rule of thumb which is not guaranteed to do anything, but quite a lot of well, so it's a very simple rule is to pick the one that's closest to 1/2, the most fractional, closest to the farthest away from an integer number. So in this case, this is very close to 0, whereas this is close to 1/2. So that's what you would have to pick normally. But because it's a hard problem, it doesn't guarantee that the most efficient way of solving it. So okay, so x3 is better, and it's either equal to 0 or it's greater than or equal to 1. And you can call these problems whatever you want, S3, S4, for example. Which one do you want to solve now? Yeah, I do S3 now, because I know where it's going. But yeah, no way of knowing. So when you solve x3, what you get is 0.27 what? Roughly. This. And that gives 21.4. So you have to branch. The only thing you can branch on is x1. I want to solve this one for some reason. So when you solve this, you get 0, 7, 0, 21. That's the objective. Do you have to branch? No. Do you write proved integer? It's already all integer. The other one, 17, 1.50. What is infeasible?
It's worse than the best integer solution. So it's,
Pruned, integer, and also suboptimal. The last unsolved problem is S4, and you get 0, 6.51. Just a branch? Why not? Because what I should have said is in complement. 21. Now, this is less than 21, so I can say suboptimal. Optimal solution. Because that's actually very close to the first realization, but many times it's not. Any question? So what's hard about this question? What's the most difficult bit? The most bit, that's what you need to practice.
You just use Excel.
You can use Excel. In what way?
Use the solver.
And who? We have to be smart about how you're adding these constraints. The limits. So you have to think it through. But you can use Excel. You can use Excel in the simplest method, or you'll run out of time if you do. So I wouldn't recommend it. Okay, and there's part B as well. This was question 8. And this is just like the second part of the assignment. Okay, sorry? Yeah, IOPs, exactly. So the way it goes is that you say that 5 over 2 x1 plus x2 plus 1 half x3 plus 1/2 S1 equals 15/2. Therefore, 2x1 plus x2 is less than or equal to 15/2. Zero and negative. So if you take a smaller multiple of each of them, the sum is getting smaller. It's less than time. Okay. And we'll move writing. 2x1 plus x2 is an integer. X1 and x2 are required to be integer. So you can safely say that there are no more than 2, 7.